I wrote pause here. Hey, let's no longer pause here. We were talking really quick. You guys can stay on this page very quickly. What have we been reviewing? We've been doing a very quick review of some of the stuff you learned in grade 8. We talked about the main states of matter, solid, liquid, and gas. We said that kinetic molecular theory, which we decided to abbreviate as KMT, says as you add heat to an object, to a substance, the molecules gain kinetic energy, the particles gain kinetic energy, and they start to move back and forth faster. And as they move back and forth faster, they tend to move further and further apart. That's why when you heat up a solid, it turns into a liquid, becomes sloshy. Continue heating it up, it turns into a gas, because that's as far apart as the particles can move. When you reverse that, when you remove heat, when you remove kinetic energy, the particles move slower and slower. They get closer together, first into a liquid, get slower and slower, and then into a solid. Although you can go from a gas directly to a solid, skipping the middle step. You can go from a solid directly to a gas, skipping the middle step. In fact, what I said to you was you're going to have to know some of the terminology. So I think I said, I like this diagram, I like this diagram, I like this diagram. You can expect, you know what, I'll probably take this diagram, remove the words, and say, can you fill in the words? The good news was we knew some of them. Melting, most people know. Solidification, even if you don't know the word, hopefully it's pretty obvious that solidification becomes a solid. Oh, I just noticed that. Okay. Evaporation and condensation. Most of you know the words. It's easy to get them mixed up. I know evaporation is liquid vanishing, so I know condensation is the opposite, becoming a liquid. The two more obscure ones are sublimation and deposition. We talked about that as well. We did the reading check, we quizzed each other, and we're right here. So describing matter. Physical properties are characteristics of matter that can be observed or measured. And we have two main types. We have what we call qualitative properties. Hey, Mr. Dueck, you mentioned that word a couple of days ago in that whole Simpsons science. Oh yeah, we're you know. Your teenagers all tend to repeat things. I find that repeating things help teenagers learn better. Repeating things, I find, helps teenagers learn better. Repetition can cause teenagers to learn better. Yeah, okay, anyways. These are properties that can be described but not measured. You can't put a number on it. And then, hey, what was the other one? We had qualitative, and do you remember the other word that began with a Q? Quantitative. Nice. Quantitative. These ones can be measured numerically. I know that the word quantity means how many. That's how I remember, it can be measured, you can count it. Quantitative. Qualitative is not quantitative. That's kind of how I remember these. So let's talk about these. Some words. I wrote C chart on page 22. We're going to fill it in together, but if you're studying and you want to see a nice pretty chart that has a better description, you can certainly go to page 22. What's the word that describes whether something is a solid, a liquid, or a gas? Begins with letter S. Rhymes with gate. State. That's a qualitative. You don't measure how much of a liquid or how much of it's a solid or it's a liquid or it's a gas. It's not a 3.6 gas. Doesn't make sense. Okay? Color, which also it says right there. Little fussy. Water, we do not call clear or transparent. We call water colorless. The reason is transparent doesn't mean clear. Coca-Cola is somewhat transparent. We would say Coca-Cola, or you know, most sodas are. Apple juice is transparent. So if you're describing something as looking like water, we use the word colorless. We don't use the word clear. We don't use the word transparent. If you can see through it, you use the word transparent. Apple juice is transparent. The ability to be beaten into flat sheets, we call that Malleability. Something is malleable if you can beat it into flat sheets. Most metals are malleable, which is why we use them to make stuff. Ductility is the ability to be drawn into wires, also most metals. I know what a heat duct looks like. It's those pipes. So for me to remember that this means they can be drawn into wires, those heating ducts sort of look like giant wires. Use your imagination and shrink it down, Lyndon, and then hopefully you can keep track of these words. Some of these words are going to be fair game as vocabulary on your first chapter test. New words, I know. You'll be using them in the homework, and I'll be giving you a little crossword puzzle later on too. The shape or appearance of crystals, we call this crystallinity. Crystallinity. Giovanni, I'm going to argue that one, the word crystallinity, the fact that it means that it appears like crystals, that one's fairly easy to remember because it has the word crystals in the actual word. What do you think we call something that has the tendency to be attracted to a magnet? Yeah, magnetic. Magnetism. Magnetism, which is also fairly easy to remember because it has the word magnet in it. Tristan says, well, I have a magnetic personality. No, that's your mom saying that to be nice, but believe me. Okay. Oh, someone else late? Let's see. Continuing on. Some quantitative, some things that you can measure. So the ability to dissolve in water, we have a fancy science word for that. We call that is there an A in there? I don't think there is. No, solubility. Can you see sort of the word dissolve, at least part of the word dissolves appear at the front? So that's the way you can kind of remember that one. The ability to conduct electricity or heat, we call that conductivity, and that one's not too bad because the word conduct is in the word conduct, I can't even spell, conductivity. This one you might know, it's a little obscure. Resistance to flow, it's a fancy word for something that's really, 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 really thick and doesn't want to flow well. It begins with the letter V. Yeah, someone said, you're right.
Yeah.
Go for it.
Oh,
Viscosity, nice. You know what? There. Oh, nerd candy for you. Viscosity. Viscosity. Yeah, that works. Ketchup has a high viscosity until you agitate it. The ratio of a material's mass to its volume. We call this density. What we're saying is it doesn't take up much space, but it's really, really, really heavy, then it's very dense. Lead is very dense. The temperature of melting or freezing, we call that the melting / freezing point. And you can measure that. Most of you know the freezing point of water. In Celsius, what's the freezing point of water? 0. What's the boiling point of water? No, that's the freezing point of water. What's the boiling point of water? It's also a nice round number. This is why the Celsius scale was set up that way. Yeah? 100. Okay, water boils at 100. Celsius, and it freezes at 0 Celsius. Now, if you're in the US and you're doing Fahrenheit, does anybody know what the freezing point is in Fahrenheit?
Of what?
Water. Not 0, it's a stupid number. Okay, 32 degrees. And the boiling point of water in Fahrenheit is 212 degrees Fahrenheit. One more reason why metric is nicer. Temperature of boiling condensing, so we would call this the boiling / condensing point. Probably what I will do is I will take, how many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll probably take 6 or 7 of these and I'll set up like a little matching thing on the test. That will be a way to kind of see which ones of these do you know. So I like these words. I like these questions. Make a little note next to these if you want, whatever you need to do to let yourself know this is fair game for a test. A pure substance is a substance that is made up of only one kind of matter. There are 2 kinds of pure substances, elements and compounds. We're going to be learning this year. So an element is a pure substance that cannot be broken down or separated. Elements are what you see on that big poster behind Tristan on the wall. That's the periodic table of the elements. That's the alphabet of the universe. Everything in the universe is made up of those. In fact, everything in the universe is made up of the first 92 of those. After that, we create them in labs, so we can create them here on Earth artificially, but as far as we know, they don't show up in the universe at all. And even the ones that we create in labs artificially, most of them only exist for trillionths of a second. But we can make them. A compound is a pure substance that's composed of 2 or more of those. You are all made up of compounds. Yes, some elements, but most of the elements in your system are not isolated. They're combined with other stuff. Okay? Water, which is H2O, hydrogen and oxygen. Table salt, which is sodium and chlorine, sodium chloride. Rust, which is iron and oxygen. They're compounds. Video instant ice, I showed you this last day, right? Any of you try it yet? If you're bored, that's a fun one to do actually in the summertime, because even if you get it wrong, hey, I got cold water, so it's win-win. Homework I wrote here, section 1.2 homework. So I think I gave you this last day, right? So part of the homework today, you're going to work on this. I also got something else to give you. So section 1.2, did I attach the answers? I can't remember. You guys have the answers attached? And I did my rant about not being silly and just copying them and cheating, right? Okay, don't be that. Now, what I want to talk about is this one here. Can you get out the changes in the homework from last day and find the changes in state in gold? So your homework is finish this and then also finish the crossword sheet. Don't forget that there's something on the back.